Hello, this is Dr. Strickland. In this video, we will investigate how benzene reacts. Take a minute to read through these student learning objectives. These are the things you should be able to do by the end of this video so that you're ready for the more difficult things we will do together in class. The reactions of benzene are called electrophilic aromatic substitutions, and they start out the same as an electrophilic addition, but the second step is different. So if this were an electrophilic addition, then you know that in the first step, the electrophile would add, and you would get to this carbocation intermediate. And in the second step, you've got a nucleophilic attack. And so let's call our nucleophile Z, and we'll make it negatively charged for today. And so, if this were an electrophilic addition reaction, this would go right there, and you would end up with something that looked like this. Now, if you've been thinking about aromatic systems, then the problem with this is that the aromatic system is lost. That fully delocalized set of pi electrons is gone because we've introduced two sp3 carbons now. And so you can't have that full delocalization, which we think is what makes benzene so super stable. Instead, this electrophilic addition, where the electrophile adds in the first step, is followed not by a nucleophilic attack, but instead by a deprotonation. And so some sort of anion that's in there does react with benzene, but not as a nucleophile, reacts as a base. And so instead of getting an electrophilic addition, what we get is an electrophilic aromatic substitution. And the reason that's important is because what it does is it reconstructs that fully delocalized system of the benzene. So this is what happens. This doesn't happen at all. All right, so we will have a lot more to say about this, but before we leave this general discussion, I wanted to show you just in graphical terms what that looks like. So in the first step, we form the same intermediate. We form this carbocation. So if I were going to draw a free energy diagram, then it would go the reactants, some sort of transition state, and then you've got this intermediate form. And then in the second step, we have a choice. We can go there, or we can go there. And this one is the result of electrophilic aromatic substitution. This one will be the result of electrophilic addition. And this one wins because this produces a product that's so much more stable. And so many things in organic chemistry have to do either with the production of the more stable product or with the more stable intermediate. In this case, the intermediate is the same, but the products have very different stabilities. Okay, so the general mechanism for an electrophilic aromatic substitution reaction is just like we just did. But I wanted you to have it down here because it will be the template for everything that we do with benzene reactions in the future. So the addition of the electrophile followed by the deprotonation gets you to the product where the electrophile has been substituted for one of the hydrogens on the ring. All right, and so that is the basic story on how benzene reacts. If you have any questions, please send them to me.